Okay, good morning. So I hope that you have enjoyed your Christmas and New Year holidays and that you are fresh to go back to work. So I want to go to the next chapter in this Math 5. And if you have seen the book, the first section is the review of probability theory that you in principle should have learned when you were doing Math 1C, okay? So I'm not going to repeat that part. I immediately skip the part that is to be, it's called Combinatorics, which is a very important branch of discrete mathematics. And then if we need, so if you study that part, because there will be some problems in this section that is related to probability theory, not very hard ones. If you think that we need to go through it, then just please tell me so that I can dedicate 1 or 2 sessions to review probability theory. But for the time being, let us try to start from this new lesson, which is called Combinatorics. So if you know that in Mathematics 5, we are studying that branch of mathematics, which is called discrete mathematics. So far we have learned about set theory, and then we learned about number theory. Another big branch of discrete mathematics is what is called combinatorics, and that would be the topic for today's lesson. So in order to motivate you, so I cannot give a very precise definition of what combinatorics is, but might be you can say that any problem somehow related to enumerating the number of items of something is somehow related to combinatorics. For example, if I am right, I haven't done any research about that, but as I see the registration plates for cars in Stockholm or in Sweden, it consists of 3 letters and 3 numbers, for example. Let us, for the time being, assume, I don't know if this is true or not, but let us consider that the 3-letter part is actually English alphabet and the numbers are not including 0, for example, 1 up to 9, yes? For example, you have a registration plate like ABC, and I don't know, 1, 2, 3. That is one registration number for a car. So you want to see that how many cars we can register using this system. Yes? So this is one motivation problem for this topic. So of course this is not a hard problem at all. At the end you can sit down and write all the possibilities for yourself and try to count them. But the point is that this is not practical at all. One way is to write a code to generate all of them and ask the computer to calculate the number, okay? But we want to learn, is there any way that we can know how many cars we can register using this system without going through the process of writing all the items and counting them? Yes? So this is the question that we will be able to answer very soon. So we want to develop some tricks and techniques to be able to answer these sorts of questions. We want to enumerate the number of items of something without actually going through the process of generating all of them and sit down and counting. So that is more or less the thing that you expect in this section. Combinatorics problems are very easy to design, but sometimes very, very hard to answer. Okay, so what you should expect is that the questions are easy to understand, but that it doesn't necessarily mean that you have to answer it very quickly. The answers are just one single number or whatever. So I want to ask how many cars I can register using this system. At the end it is a number. Sometimes reaching to that number is extremely hard. Okay, so we have to start learning the fundamental principles that we have learned so far. For example, the product rule and the sum rule, to learn about them a little bit deeper so that we will be able to answer harder questions in this case. Yes? Okay. Any questions so far? So if I want to summarize, we want to count the number of items of something without going through the process of enumerating them case by case. Okay, the first thing that we want to learn today is the product rule. Okay. So in the beginning, it might seem a little bit boring, but I really want you to trust me on that and try to learn it in this way that I am telling you. Otherwise, it could be a little bit problematic if we go further for harder questions. So let us start with a very simple version of the product rule. Of course, if we have, for example, you already know if I have 2 students, 3 students, each one of the students have 5 books. If I ask how many books are there, you can just multiply 3 by 5, it's 15. It's more or less the product rule, yes? But we want to write it in a more precise way, which is more suitable for our case in this case. So, assume that you have a task. This task can be performed in 2 stages. So stage number 1 and stage number 2. Yes? So you have a task that can be accomplished after 2 stages are done. And then you have, for example, N1 options for performing the first stage, and then you have N sub 2 options for performing the second stage. Okay, but the point is that N2 should be independent of the way that I do the first stage. Yes? So assume that you have a task. This task can be accomplished in 2 stages, stage 1 and stage 2. And when stage 1 and stage 2 are accomplished, I can say that my task is done. So assume that this is the case. Now assume that the stage 1, for performing stage 1, you have N sub 1 options. And now assume that you have already done stage 1 with one of these options. And now stage 2 can be done in N sub 2 ways, independent of the way that I have done the first stage. That phrase is extremely important. Yes? In that case, for accomplishing this task, how many options I have in total? I have N1 dot N2, N1 multiplied by N2 options available for performing the task. Yes? For example, so assume that you have a project, you want to find 2 persons to do this project. For this project, you need a physicist, for example, and you need a mathematician, yes? So, for example, assume that the number of physicists that are volunteered to do the job are 5. The number of mathematicians, so physicists, the number of physicists, yes, is 5. The number of mathematicians is, for example, 7. So you want to set up a team to do a work on some project. You need 1 physicist and 1 mathematician for setting up that team. Yes? And now you see that there are 5 physicists who are volunteered to do the job, and then you see that you have 7 mathematicians that are willing to do the job. And now you want to set up this team. Well, let us see how many ways we can do that. It's a very extremely simple problem, but I want you to really understand this problem from this point of view. So, I want you to write something for the task. What is the task here? In the exam, I really don't want you to write it down, but if the problem becomes harder, you need to think in this way. You need to define a task for yourself. So what is the task here? We want to set up a team. Yes? Setting up a team consisting of one physicist, let me make it short, and 1 mathematician, yes? So this is something, I don't want you to write exactly my words, but this is the way that you have to think about. This is the mindset, yes? So the task here is setting up a team consisting of 1 physicist and 1 mathematician. But this task can be accomplished in 2 stages, yes? One stage is choosing a physicist, one stage would be choosing a mathematician, yes? So this is my task, this can be performed in 2 stages, yes? I can call stage number 1 choosing a physicist. Physicist. Yes? And stage number 2, choosing a mathematician. Okay. So if I want to have my task accomplished, I have to do stage 1 and stage 2, not stage 1 or stage 2. I have to have both of them. Okay. But how many ways I can do stage number 1? How many options are available for me if I want to perform just stage number 1 according to what I have written on the board? How many ways I can do that? 5 ways, because I want to choose a physicist and there are 5 physicists who are volunteer. So I have 5 options available. So the number N1 in this problem is 5. Okay, but the point is that usually the first stage is we don't have any problems with it. In stage 2, you have to consider one very important point. So how many ways I can do stage number 2? How many ways I can perform stage number 2? I have 7 mathematicians. What should I write for N2? What should I write for N2? 7. But when you want to write 7, make sure that you understand this part. The number 7 that you put here should be independent of the way that I have done the previous stage. Yes? What does it mean? It means that it doesn't matter for me which physicist is chosen for the first stage. The second should be always 7. Yes, I will give you examples to understand this point better, but this is extremely important. Here, this problem was so simple that you really understand that independent of which physicist is chosen in the first stage, I still have 7 options available for the second stage. So the number that you put here is independent of the way that you have done the previous stage. Yes? If this is the case, then it means that the product rule is applicable and I can use it. Okay, so then the answer to this question is simply just N1 times N2, which is 5 times 7, which is 35. So it means that I have 35 options available if I want to set up this team. Yes, is that clear? But of course, this is very simple problem, I know, but please try to understand these things that I'm mentioning exactly for this problem. Okay, one thing is good to understand. So here, in combinatorics, we care about the numbers usually, but that is extremely important to understand what you are counting. For example, here, how many physicists I have? Let me call physicist number 1, physicist number 2, physicist number 3, 4, and 5. And then I have 7 mathematicians, yes, M1, M2, M3, M4, M5, M6, and 7. Okay, one of the choices for me to set up this team is to write P1 with M1, yes? It means that I have chosen physicist P1 from physicists and mathematician M1 from mathematicians. This is one possible choice, yes? Another possible choice is, for example, I choose physicist number 4 and I choose mathematician number 2. This is also one possible choice. So if I ask you what is this 35, you would tell me that if I start listing all possibilities and count them, the number of items that I will see is 35. Yes? Another way to see this is also this tree diagrams. Yes? For example, I have my first stage. I can have these options. Yes? I can choose physicist number 1, physicist number 2, physicist number 3, physicist number 4, and physicist number 5. If I have chosen physicist number 1 for my second stage, I have how many options available? 7 options, yes? 1, 2, 3, 4, 5, 6, and 7. So it becomes mathematician 1, mathematician 2, up to mathematician 7. But it doesn't matter if I have chosen P2, it's still how many options are available for me for the second stage is still 7. Yes, 1, 2, 3, 4, 5, 6, and 7. And if I have chosen P3, there are still 7 options available. So you see that the branches coming out for the second stage is always 7, independent of which physicist I have chosen. That is the crucial part if you want to learn this product rule in a very good way. Is there any questions so far? Okay, let us understand. These techniques I want you to learn. For example, I have given the priority to choosing a physicist first and a mathematician as the second stage. But do you think I could interchange them? The task is setting up a team consisting of physicists and one physicist and one mathematician. In this case, I have defined stage 1 choosing a physicist, stage 2 is choosing a mathematician. Could I do it the other way around? Yes. For example, stage number 1 choosing a mathematician, stage number 2 choosing a physicist. Yes, there is no order involved here. We expect that the answer should be the same. But is the answer the same? If I have chosen stage number 1 choosing a mathematician, instead of N1 to be 5, N1 is 7 this time. Yes. And independent of which mathematician is chosen for the first stage, I have 5 options available for the second stage. Then the answer would be 7 times 5, which would be again 35. So all these things that I mentioned here might seem very trivial, but please pay attention to them. Okay. Let me give you an example to make sure that you understand what is the meaning of this phrase, independent of the way that the stage 1 is done. Okay, so let us consider 2 towns. I have town number 1A. Let us call town A, town B, and assume that there are 5 roads that connect these 2 towns. Okay. So let me ask you this question. In how many ways we can go from A to B and return back? Yes? Under this condition, we are not supposed to choose the same road for the return as the road that we have chosen to go from A to B. Yes? From A to B, I choose one road, but I give you one constraint. Do not choose the same road for coming back. Yes? So in how many ways you can choose these roads? So the question is that. So let me, I am standing here. My goal is to go to B and come back to A, but there is one constraint. I am not allowed to choose the same road for coming back. Assume that all these roads are two-way roads. This is a crucial, okay? All these roads are two-way roads. So in principle, so let me take this constraint away. In how many ways I can go to B and come back if there are no constraints at all? Yes?
25.
25, yes. So what is the task? How do you define the task in your head? The task is to choosing 2 roads, yes? One for going and one for return, yes? How many ways I can do the first task? The first task is to go from A to B. The second task is going from B to A. Yes? So you need to think in this way. It is a little bit time consuming for these very simple problems, but I really want you to have your mind set up in this way. So the first task is to go from A to B. How many options are available for me? I can choose 5. I can choose any one of these rows. So I have 5 options available. So I can say for stage number 1, I have 5 options available. Now assume that the first stage is done. What does it mean? It means that I have chosen one of these roads. And now I am in B. And I want to go back to A. How many options I have now? This you should be careful into. How many of them are there for me? If there are no constraints, 5. But when you want to write this 5, think a little bit. Is this number 5 independent of the road that I have chosen in stage number 1? The answer is yes or no?
No, it's dependent.
Why?
Because you can't go
No. I'm sorry. I actually confused you. I am solving without any constraints right now, and then I will go to that problem. This is the without constraint. Yes. So can I write 5? So let me ask you in this way. For writing this 5, do I need information about how the first stage is done? We don't need it, yes? This is always 5, yes? And so this means that the product rule is applicable, so the answer is 5 times 5 is 25. So you see, let me repeat this. I am solving this problem for the time being. There are no constraints. You can choose whatever you like from A to B and whatever you like from B to A. The answer is 25. Yes? But now, let me put the constraint. The constraint is that I want to go from A to B and back from B to A under this condition. I am not allowed to choose the same road for returning back. Okay? Is the task the same? The task is still the same. The task is to find a possible combination of roads for going from A to B and returning back. So the task is more or less the same. But this task can be accomplished again in 2 stages. The stage 1, I choose the road for going from A to B. Yes? So how many options are available again? I want to choose a road from A to B. I have 5 options available. Yes? Okay, but now, for N2, what can I write here? I want to go back from B to A, but I'm not allowed to choose the same road that I have chosen from A to B. Yes, Amanda? 4. Is this 4 that you put here needs information from how you have done this or not? No, be careful. Because if you say yes, it means that the product rule is not applicable. So is this number 4 that I put here independent of how I have done this? I'm not saying, you see, I am not saying is this independent of that. I am saying is this number independent of how I have done the first stage. So let me consider this. So let me give this name. This is road A, this is road B, C, D, and E. Yes? One of these options is that you have chosen road A to go from A to B. Yes? So it might happen that you choose A. But when you want to go back, how many options are available for you? You can choose whatever you like except A. So it means that you can choose B, you can choose C, you can choose D, you can choose E. But one of the options for the first stage is that you have chosen B. Okay? But how many options are now available for you to go back? Again, 4 options. The number is independent, you see. But the way that I can do the second stage depends on how I have done the first stage. This is not important. This number should be independent of how I have done it in the first stage. So let me tell you, if I have chosen B for going from A to B, what options I have available now? I can choose A. I cannot choose B because I'm following the constraint. But I can choose C, I can choose D, I can choose E. How many branches again are coming out? 4 branches. And here we have 4 branches. It is clear that the names are different from here, but the number of branches is still 4. Is that understandable? Let us go to the next one. I could have chosen C for the first trip. Yes? So what are the options available for me? I can choose A if I want to. I can choose B. I cannot choose C because I'm respecting the rule. I can choose D. I can choose E. Again, you see that these names, the names are different in each case usually. But the number of branches is still 4. Is that understandable? So if I tell you, if you want to write 4, this number is independent of how the first stage is done. Yes or no? Is this phrase understandable? So if this is the case, it means that the product rule is still applicable. Yes? And then it means that what would be the answer to this problem? The answer would be 5 times 4, which is 20. And of course, this is not very strange. Yes, if you want if you don't want to follow these rules, this is the diagram that you draw, and then you count the number of possibilities, yes? It is clear that how many branches I can have. For the first stage, I have 5 branches, and for each one of them, I have four branches coming out. And if I ask you how many branches I have at the end, it is clear, 5 times 4, yes? So still, this seems, be careful about, this number is independent of how I have done here. But the way that I do this is not independent of that. Okay, but still the product rule is applicable. Yes? But now let me just try to make this very clear. Let us assume that 2 roads are one-way roads. Okay? Now, the same problem, I want to go from town A to town B and return back. I do not want to choose the same road for returning back. But now, 2 of these roads are one-way roads. Okay, now let us see if the product rule is applicable or not. Okay, let me ask you again, I have the same task. I have 2 stages. Stage number 1, choosing a road for going from A to B. So how many options are available for task number 1? How many options are available? Yeah?
Still 5.
It's still 5. Okay, but now, how many options are available for stage number 2?
It's dependent.
Yeah, it depends. That is the crucial part. If it depends, it means that the product rule is not directly applicable. Yes? Why it depends? Because it might happen that I have chosen A, it might happen that I have chosen B, C, D, or E in the first stage. Yes? If I have chosen A for the first stage, what are the options available for me if I want to return back? I have only C, D, and E available. Yes, C, D, and E available. But if I have chosen B, how many options are available? C, D, and E again. But if I have chosen C, can you tell me how many options are available? If I have chosen C, I cannot choose C because of the constraint in the problem. I'm not supposed to choose the same track to go back. But A and B are one-way roads. I cannot choose them. So how many options will be available for me? Only D and E. Yes? If I have chosen D, how many options are available for me? Only C and E. And if I have chosen E, how many options are available? Only C and D. So hopefully you understand what I mean. You see, the number of branches coming out for the second stage is not always the same. It changes. And it is clear that it is wrong to say 4 times, 5 times 3 or whatever. I need to write, if I want to really answer this question, I would say that I have 2 branches, 3 branches are followed, so it means 2 times 3 plus 3 times 2. So that would be the real answer to this problem. But only the product rule on its own is not applicable for this problem. Is that clear? So I want you to understand this phrase. That is extremely important. I don't want, of course, the answer to this problem is very simple. 2 times 3 is 12, and 2 times 3 is 6, 3 times 2 is also 6, and then 6 plus 6 is 12. So, but this is, I am using another rule, which is the sum rule. I am multiplying, and then I am adding. That would be another rule. But for the time being today, I want to discuss only about the product rule, and I want you to understand how you need to think about the product rule. So that is extremely important to understand this phrase of this number being independent of how the first stage is done. If that is the case, you can directly use the product. Okay, any questions here? For example, let me just give you some examples. For example, how many 2-digit numbers are there? Of course, this is a very, very simple problem, but I want you to use the product rule to answer this question. How many, so let me write example. So we are practicing this rule today. So how many two-digit numbers are there? Of course, this is a very, very simple problem. You really don't need the product rule to answer this question. What is that number? Without any product rule, yes? The first digit number, the first two-digit number is 10. The last two-digit number is 99. So how many of them are there? Yes?
89.
No? Be careful. This is usually people make mistakes. From 10 to 99, how many numbers are there? Yes? 90, because you are also counting 10. Yes? For example, if I ask you how many numbers are from 1 to 10, this is clearly 10. But if you write 10 minus 1, it becomes 9, which is wrong. Yes? So you need to remember that if I ask you how many numbers are there, you need to count this way. So then this is clear that there are 90 two-digit numbers there. Yes? But let me try to understand this problem using this product rule. Okay, if you want to use the product rule, please think in this way. You need to define for yourself, even at least in your brain, a task that you want to do. And then you need to divide the task into two stages and define each stage for yourself. Even if you are lazy to write it down, but you need to think in this way. Otherwise, you will face serious problems if the problems become hard. Okay? So what is my task here? If you want to say something about the task, writing down, for example, a two-digit number is my task. This is the task, yes? Okay, I can divide this into two stages, yes? Stage 1. Think in this way. What is the stage 1? Usually we write numbers from left to right, yes? So I can say that choosing the 10th digit of that number, yes? Because you write a number, for example, 12, this is called the units digit with an S, and this is called the 10th digit, yes? Yes, 10th. I think there is also an S at the end of this. I need to check it out. Okay, but this is the 10th digit, that is the units digit, yes? Okay, so if I want to write a two-digit number, even though I write it very quickly and I really don't care about these processes, but stage number 1, your brain decides about the 10th digit, and then your brain decides about the units digit, yes? When I ask you to write a random two-digit number here, of course you do it so naturally that you even don't think about it. But you really do that. For example, I wrote 12. My brain decided about this number and my brain decided about that number. So this task can be accomplished in two stages. Stage number 1, choosing the 10th digit. How many options I have for stage number 1? How many options I have?
9.
9. I can choose all the digits except 0. Yes? Because otherwise that would be a single digit number, not a two-digit number. So I have 9 options available. Stage number 2. For stage number 2, you need to think in this way. Assume that the first stage is done. What does it mean? It means that I have already decided for the digit that I want to choose for this digit. Yes? This is the meaning, assuming that this is done. Now, for the second stage, how many options you have? 10. But before writing 10, you need to convince yourself that this number that I put here is always the case, independent of how the first stage is done. Yes? It means that one of the options available for stage 1 is to choose 1. How many options are available for me for the units digit? 10. I can choose whatever I like again. Even if I have chosen 5 in the first stage, how many options are available for me again? 10. It doesn't matter which way I have done the first stage, I have always 10 options available for me. So is the product rule applicable in this problem? Yes or no? Yes. So it means that the answer is, the total answer is 9 times 10, which as you predicted, is 90. Yes or no? Okay, but one piece of advice is don't think that you have to count naturally. For writing a two-digit number, I naturally start from left to right. Yes, but here you are assuming counting. Sometimes, I will give you examples, sometimes it is crucial to interchange the role of a stage 1 and 2, even if it is not natural. Yes, but let us check in this case. If I have chosen stage number 1 to choose the units digit, yes? So let us interchange to see if there is something odd going on here. So if I have chosen stage number 1 to choose the units digit, then how many options are available for stage number 1? 10. Agree? Because I can choose 0 here as well. Okay, now I go to stage number 2, which I'm supposed to choose the 10th digit.
9.
How many options are available? 9. Yes, because, and is this 9 independent of the way that I have done here? It is. So, yeah, it is. It seems that this is also applicable. So the question mark in this case would be 10 times 9, and the answer would be 90. Yes? So this means that this is completely consistent. Any questions here? Okay, so let me now make this problem a little bit more interesting. Of course, even in this case, that is very simple. Assume that I am asking you this question: how many two-digit numbers are there without repeated digits? Okay, but of course, this question is also very, very simple to answer. But I want you to, so let me write this down. Example: how many two-digit numbers are there? How many two-digit numbers with distinct digits are there? Okay, let us answer this question. Of course, you really don't need the product rule to answer this question. Can you just immediately tell me how many of them are there without the product rule? Yes? 81. For example, one way to think about this is that how many two-digit numbers are there? We know there are 90 of them. But 11, 1 is repeated. 22, 2 is repeated. 33, 3 is repeated. I want distinct numbers with distinct digits. So I need to take 11 away, I need to take 22 away, 33 away. How many of them are there? 11, 22, 33, up to 99. How many of them are there? 9. So I had already 90. 9 of them are not acceptable in this problem, so I take them away. So there are only 81 left for me. Yes, that's one way of thinking about the problem. But let us try to solve this problem using the product rule, if applicable. Okay, so the task is again the same. The task, not the same. The task is to write down a two-digit number with distinct digits. Yes, this is my task. I can divide this task into two stages. Stage number 1, choosing the 10th digit, and stage number 2, choosing the units digit. Okay, how many options are available for me in this one? No, this I'm just writing it naturally, okay, from left to right. Yes, N1 is the number of options for the 10th digit. How many of them are there? None. The only problem for me is 0. I cannot choose 0. Yes, so I can choose 9. I have 9 options. But how many options are there here?
9.
Okay, can I write 9 or not?
Yes. Yes.
Yes? Now this is important. I want you to think. Yes? Can I write N2 is also 9? Okay, just tell me, is it independent of the way that I have done it first? So let me write the numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in the first one, I know that 0 cannot be chosen, so I have 9 options available. But when it comes to the second stage, be careful. You are not allowed to repeat the first one. Yes? Okay. So how many options are available here? Yes? Okay, let us check. If I have chosen 1, I have to cross 1 away because I am not allowed to repeat it here. How many options are left for me? 0, 2, 3, 4, 5, 6, 7, 8, 9. How many of them are there? 9. But if I have chosen 2, I should cross 2 away. Then how many of them are left for me? Again, 9. So you see, this 9 that you want to write here is independent of the way that you have done the first stage. So this means that you can write 9 and make sure that this is applicable. So you can assure that this is applicable. The product rule is applicable. So the question mark is 9 times 9, which is 81. Yes? Is that clear? Okay. In the previous problem, do you see, I was able to interchange these two stages. In the natural way, I started from the natural way, I got 90. I interchanged these two stages. The product rule was still applicable, and I got 90 again consistently. Yes? But let us ask you this question. Can I interchange the role of a stage 1 and a stage 2 in this case and still make sure that the product rule is applicable? Yes? This is my question now, because I want you to understand these details. Now the question is that if I want to choose stage number 1, so here, stage number 1, stage 1, 10th digit. Yeah, there should be an S, I think, at the end, but... So, stage number 2, units digit. Yes? This is the way that I define it myself. I am free to choose whatever I like to, okay? This was the natural way to do it. Now, for understanding things better, I am asking you this question. Could I have chosen stage number 1 to be the units digit, and stage number 2 a 10th digit? Yes? If I have chosen it in this way, can you tell me how many options are available for N1 and how many options are available for N2? How many options are available for N1 if I want to choose the rightmost digit here? How many options are available there? How many? 10, yes? I have 10 options available. But now, how many options will be available for N2? Is the number that you want to write here is really independent of the way that you have done the first stage? If you think it is not independent, yes? Let me write it here. So let me go back to this. When I write 10 here, one possibility for me is to choose 0. Yes? So if I have chosen 0 in the first stage, how many options will be left for me for the second stage? 9. Any number from 1 to 9. Yes? So this might be 9. But this depends. If I have chosen 1 in the first stage, for the second stage, I have to cross it over because I'm not allowed to repeat the digit. But 0 is also not possible to choose for the 10th digit. Yes? So how many options will be available for me then? It would be 9 or 8. Is that understandable? So in this case, the 10th digit, I'm not sure. Is it 9 or 8? It might be 9 or might be 8, depending on how the previous stage is done. So it means that if you define the stages for yourself in this way, there is nothing wrong about it. But I want you to understand, if you define it in this way, the product rule is not directly applicable to this problem. Because then you have 10 options available here, or 8 options available. If not, sorry, if you can write 10, but you don't know, you should write 9 or 8. Because for some cases, you have to write 9. For some cases, you have to write 8. So this means that this number that you want to write here depends on how you have done it in the first stage. Is that clear? So this is very important thing. I want you to understand that sometimes interchanging the role of these stages will help you to use the product rule. So this is one trick I want you to learn. But sometimes it is not possible. We need more rules. Okay? Okay. This is understandable, hopefully. Any questions here? Okay. Now let me ask you another question. How many odd two-digit numbers are there? Okay, so let me ask you this question. So let me write here. The product rule is not applicable, directly applicable. Okay, so another example. How many odd two-digit numbers are there? If number 1, the repetition of digits is allowed, 2, repetition of digits is not allowed. Okay, so let us answer this question. Of course, these questions are very, very simple. But by the way, if I ask you the same type of questions for 3-digit numbers, or if I ask you the same type of questions for 4-digit numbers, then I hope that you agree with me. It is not that easy to answer them. Then probably today we will learn how to answer those questions as well. But for 2-digit numbers, the problem is so simple that you can find a way without using actually these rules that I am talking about now. Okay, how can I answer this question? Let us focus on this first part. Again, think in this way. What is your task? Your task is to write down a 2-digit number which is odd. This is your task. Okay? This task can be accomplished in 2 stages. Stage number 1, for example, choosing the left digit. Stage number 2, choosing the right digit. Yes? This is the natural way of writing. If I ask you to write a 2-digit odd number, for example, you write 25 for me, the problem is so simple that you immediately understand what is my question and you write one of those numbers here. You write the first digit 2, the second one 5. How can you choose 4 here? You don't write 24 because you know that if you write 24, 24 is not odd. Even though this number is more important for you, for this problem, but you still start from the left. So let us consider the same natural order. Okay, so here, stage 1, stage 2. Let us listen to this. This is a simple but important problem. Stage 1, let me write 10th digit. I'm just being a little bit lazy. I have to write choosing the 10th digit, okay? And then units digits. Okay, can you tell me how many options are available for stage number 1? Odd 2-digit number, repetition of digits is not allowed. Yes? I have 9 options available here. The only exception is 0. I cannot choose 0 for the 10th digit. So I have 9 options available. Yes? So let me write the numbers down here in front of you. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so here the only problem for me is 0. I cannot choose 0. I can choose whatever I like except 0, so that I have 9 options available. So, N2, how many options are available for N2? Yes? 5, yes, because I want to have my number an odd number, so I can only choose from 1, 3, 5, 7, and 9. Okay, but be careful. When you want to write 5, at least take your time to think a little bit. Is this number that I have written here independent of how I have done the first stage? Is it yes or no? Is this number that 5 you put here is independent of the way that you have done it here? For example, assume that you have chosen 1 for the first stage. How many options are available for me here? 5, because repetition is allowed. Yes? Even if I have chosen 2, still how many options are available for me? Again 5. So you see that this 5 that you put here is independent of the way that you have done it here. Yes? And then this means that the product rule is applicable, and the answer is 9 times 5, which is 45, which is reasonable, yes? How many numbers we had? 90, so half of them are odd, half of them are even. So that's the same answer. Okay, now my question is to let us go to the next one. Let us see what happens. Usually we want to start thinking naturally from left to right. So let us see if I want to use to count this naturally, does it work or not? Okay, can you answer this question? So let me again insist to do it naturally, meaning that let me take stage number 1 to be choosing the 10th digit. Yes? And stage number 2 for part 2 of the problem, part 2. Stage 2, unit digit. Yes? Okay, now tell me how many options are available for stage number 1. Here, the repetition of digits is not allowed. So how many options I have for that one? I hope that you agree with me again, 9. Yes? But how many options are available for the second stage? Can I write 5 again? Yes?
5 or 4.
5 or 4, depending on how I have done it. This is crucial. So you see, N2, if I have chosen 1 in the first stage, because I am not allowed to repeat, how many odd numbers are left for me to choose? 1, 2, 3, 4. Yes? But if I have chosen 2 for the 10th digit, I am not allowed to choose 2, but how many options are available for me because I want to have an odd number? I really don't care about 2 at all. How many options are available for me? 1, 2, 3, 4, and 5. So you see, if I want to answer this question, it is not certain. It is 4 or 5. Whenever this happens, it means that the product rule is not directly applicable. I want you to understand that. Is that understandable? So, there is one trick I wanted to teach you. Sometimes, not always, sometimes interchanging the role of stage 1 and 2 will work if the problem is simple. But if the problem is a little bit harder, this is not enough. You have to know other rules as well. Test this idea before giving up. Okay? So, this doesn't work if I want to use the product rule only. But let me, the product rule is not applicable. The product rule is not directly applicable. Okay, but now let me interchange. So learn this trick. Sometimes interchanging the role of stages will work for you. So let us test this idea here. Stage number 1, I will check it. I will take it as units digit. Stage number 2, I will take it as tens digits. Let us check this idea. I don't know if it is going to, but it's based on my experience. Sometimes interchanging these roles will work. Okay, so let us see if it works or not. Okay, now can you tell me how many options are available for stage number 1 for the second part of that example? How many options are available? I want to have an odd number. So the rightmost digit number should be an odd number. How many options are available? 5. Yes, so I write 5 here. But when I go to the second stage, I want to choose my tens digit. Okay? So how many options are available for me here? Yes?
8.
What?
8.
It is 8. Yes? Yes, there are 8. Why is that? And this 8 is independent of how I have done it, yes? Because in the unit digit, I am allowed to choose one of these. So I have 5 options available. For example, assume that I have chosen 1. So I have to drop 1 from my list, drop it out, because I'm not allowed to repeat it again. But because for the tens digit, I am not allowed to use 0, so 2 of them are gone. How many options are available for me? 8. But don't be in a hurry. You need to check it once more. Assume that you haven't chosen 1. You have chosen 3. Does this choice will affect the number 8 there? No. Because this time 3 is dropped, 0 is dropped, but there's still how many options are available? 8. And it doesn't matter if I have chosen 5, if I have chosen 7, if I have chosen 9. So this is 8 for sure. This is not like this. I am certain about this number 8, independent of how I have done it. So the answer to this question would be 5 times 8, which is 40. Yes? So there are 40 two-digit odd numbers with distinct digits. Is this number sensible or not? If you want to understand it from a different way. Yes?
Yes, because there is 45 of odd numbers minus the 5 numbers which the digits.
They are repeating it, so that's completely reasonable. So you see, learn this trick, you know. If I started counting naturally, it didn't work, but if I interchange this, it will work. So, but sometimes, of course, if the problem is hard and needs more rules to apply, this trick on its own will not work. But at least I want to draw your attention that sometimes interchanging the roles of stages will help you to solve the problem. Is that clear? Yes or no? Okay. And now, if I ask you, now let us assume the natural question here will be, if my task cannot be divided to 2 stages, can be divided into 3 stages, 4 stages, then what can I do? For example, can you rephrase it for me? If I want, assume that you have a task, for example, choosing a 3-digit number. Choosing a 3-digit number is my task, but this task can be divided into 3 stages. Yes? Can you formalize the product rule? What is your intuition? Can you formalize the product rule for a task with 3 stages? Yes?
If all stages are independent, then you can use the product.
No, I want to elaborate a little bit more than that. So assume that you have a task. This task can be accomplished after 3 stages. Yes? Stage number 1 can be accomplished in N1 ways. Stage number 2, now you can participate.
They accomplished in two ways.
In 2 ways,
If-
independent of how the previous stage is done. And then after the first and second stages are done, the third stage can be accomplished in N3 stages, independent of
How N1 and
first and seconds are done. If all of these things are the way that I mentioned, then you can say that, okay, I can calculate this for the total number of options available. So then this is actually very simple. If you have a task that can be accomplished in more number of stages, the important thing is that the number that you put here should be independent of all the ways of the previous stages. Yes? If this is going to work, then it means that the product rule is applicable, and the answer to that question would be just the product of these options. Is that clear? Yes or no? Yes? Okay. Let me give you some examples. And by the way, before continuing, here, if I have asked you how many even 2-digit numbers are there, the first, you will not have any problems. But for the second stage, you will face some problems. It doesn't matter if you do it naturally or you reverse the order. None of them will work. I want you to convince yourself of that as a very important practice. It doesn't mean that we cannot solve this problem, but what I'm telling you that if I have asked about even numbers, instead of this word odd, I just write even, you still can solve number 1 with just product rule. But for number 2, you will not be able to solve it just with product rule. You have to use the sum rule as well. It doesn't matter. This will not work. Even interchanging of that will not work. Yes? I want you to convince yourself why this is the case, but then when we learn about the sum rule, we come back to this question and solve that one as well. Okay, but now let me give you some more examples here. Okay, let me ask you one question about this three-digit numbers. How many three-digit numbers are there? How many of them are there? Now I want you to think a little bit which way to calculate this number is easier for you now. How many three-digit numbers are there? Come on. Yes, how many three-digit numbers are there? Yes, Martin?
900.
900. Yes? The smallest one is 100. The largest one is 999. And again, don't fall into this trap that you subtract them. Because if you subtract them, how much you get? You get 899. But one more is 900. Yes? But if you want to do it using the product rule, this generalization of the product rule, so how do you do that? Make it simple. So let us write it. So I want to write, so I would say that this is a stage 1, stage 2, for writing a three-digit number, stage 3. For example, yes? This is the natural order. Let us see. If the natural order works, I don't bother to change the order. So how many options are available for the first stage? Yes?
9.
None, because I cannot choose 0. Every other number I can choose. But then, how many options are available here? 10. Is this 10 independent of the way that I have done the first stage? Yes. It doesn't matter which number I have chosen for the 10, for this 100th digit. I still have 10 numbers. And then how many options are available here? 10 again. Is this 10 independent from the previous and the previous one? The answer is yes. So then the product rule is applicable. 9 times 10 times 10 is 900. Yes? For example, if I ask you how many 3-digit numbers are there which are odd and the digits are not repeated? Can we answer this question? So, this is the total number of 3-digit numbers. So I want to ask you this question. I want to have a 3-digit number. Let us consider this. The odd 3-digit numbers. How many odd 3-digit numbers are there? That probably should be this number divided by 2. Yes? But let us check it from this one. Let me just choose the natural order again. Stage 1, stage 2, stage 3. How many options are available here? None. Yes? But, this is a good question. So let me ask you how many options are available here. How many options are available here? Be careful, I want to have an odd 3-digit number. How many options are available here?
10.
10. This 10 is independent of my choice here. But how many options are available here? Because I want to have an odd number, 1, 3, 5, 7, and 9. These are the only options for this. So how many of them are there? 5. Yes? Is this 5 that I have written here independent of the ways that I have done these 2 stages? The answer is yes. So the answer would be, as we predicted, this number. Now let me ask you the same question. How many 3-digit odd numbers are there, but the repetition is not allowed this time? So repetition is allowed. So now let us assume that repetition is not allowed. Okay, let us see if we can solve it now or we have to postpone it. S1, S2. Let us first take the natural order. Does the natural order work here? So let us check. How many options are available here? None. Yes? But how many options are available here? 8, yes? Because the one that I have put here is not allowed to be chosen again. Repetition is not allowed. Yes?
Yeah.
But yeah, let me write the numbers. The numbers are here. Yes, you see here. The numbers are from 0 to 9 here. So when I write 9, it means that I can choose any number from 1 up to 9. 9 options. Okay, then I fill this gap with one of those numbers. Then I come to the second stage. I want to put a number here. So how many options are available here?
8.
No.
No.
9.
Yes.
Because this time I can choose 0. But I cannot choose the one that I have chosen here. So still 9. Is that understandable?
But that way.
Yes or no?
Yes.
Okay. But now can you tell me how many options are available here?
That should be 8.
So do you see, this number is definitely 9. This number is 9 independent of how I have done it here. But let us see how many options are available here. Can you answer this with certainty? I think you agree with me that we cannot answer this with certainty, yes? Because it depends what I have done here and there. For example, is it possible to choose 1 for this digit? The answer is yes. Assume that I have chosen 1 here. So then 1 should be crossed over. And assume that, for example, I have chosen 3 here. So this 3 should also be crossed over. then I want to keep this an odd number, so there are only 1, 2, 3 options available. So I have to write 3 here. Yes?
Oh, yes.
But it might happen that in the first stage I have chosen 2. In the second stage I have chosen 4. Then how many options will be available for me when I come to the stage number 3? 5. So you see, if I want to just do it naturally, then I face a problem. Because the last one is not certain. Is that clear? There are 2 things that you need to know at this stage. Either changing the order will be helpful, or even if you do the changing of the order, it will not be helpful. It will help you in the future when we know more rules. Yes? But what do you think? Do you think that interchanging the role of these stages will help me to solve this problem using the product rule or not? These things, you see, I started with a very simple question, but believe me, it soon becomes very tricky. Yes? And I have seen students mix between product and the addition, the multiplication and addition. That comes very naturally. Okay. So, if I want to insist to keep the natural order, this is a dead end, yes? I have to divide. In this case, I have to count this not many numbers. In this case, so I have to consider a lot of cases to add them, yes? But let us think, can I change the order in a way that I can solve the problem? I am waiting for you now. Yes?
I think you can, yeah, you should be able to change the order.
Okay, let us see. This is not guaranteed, but that is a rule of thumb. Whenever you want to start accomplishing a task, give the priority not to the natural order. Give the priority to how particular a position is. Yes? So for finding an odd digit number, which one is actually more crucial than the others? If you want to write an odd number, which one?
The units.
The units digit. Yes? Even though, so don't give that, this is my advice. Okay, that's a rule of thumb. It is not guaranteed that it always works. But this is the rule of thumb. Whenever you want to write, don't always use the natural order. Use the order in which you give the priority to the one which is more particular. In this case, the units digit, as you said. So let me just write this stage number 1. Stage number 2, probably better to take this one to be stage number 2, because here I have some limitations. Here I have more limitations, yes? Here I have also one limitation, I cannot put 0 here. So that's a rule of thumb. It might work or might not work, I don't know. So then let me give this one stage number 3 this time. Let us try to check. How many options are available for stage 1? This is the simplest possible scenario. How many of them are there? I haven't started anything. I have 5 options available. So with certainty, I can put 5 here, with certainty. Okay, then let us jump to stage number 2. How many options are available for stage number 2? And is it with certainty or not? Yes? 8. Yes? 8. Why? Because you have chosen one of those odd digits and you are not allowed to repeat it, so you have to cross it over. For example, let me cross 1 over. And then I jump to stage number 2. How many options are available for me? So this number 3 is left, 1 is crossed over, and 0 I know that I cannot choose. So how many options are left for me? 8. Be careful. When I want to write this 8, is this 8 independent of how I have done the first stage? Yes. Because assume that instead of crossing 1 over, you have crossed 3 over. And then how many options are still available for you here? Again 8. You have to convince yourself of that. That this number 8 that I put here is independent of my choice in the first stage. Is that right? But when I go to the third stage, the number that I put here should not only be independent from the first stage, should also be independent from the second stage. Yes? Is it true or not? If this is true, then it means that the product rule is directly applicable. If not, we need to find another way to solve it. Okay, so now can you tell me with certainty what can I put here? How many options are available for me right now? So let me just write 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here, I have crossed one of the odd numbers. For example, let us assume that I have used 1 here. I am not allowed to use it anymore. And then, in the stage number 2, I have used one of these digits left except 0. For example, let me choose 4 in this case. 4 is gone. How many options are available here? 1, 2, 3, 4, 5, 6, 7, 8. Yes, but when I write 8, I have to be careful. Is this 8 certain, or it depends to the choices here? Is it certain or not? Yes or no? For example, let me cross these over. For example, instead of choosing 1 for the first stage, let me choose another odd number. For example, 5. And then when I go to stage number 2, I am not allowed to choose 5. I am not allowed to choose 0, but any number else I can choose. For example, I have chosen 8. So how many options are available for here? 1, 2, 3, 4, 5, 6, 7, 8. So this 8 is certain. So you need to convince yourself this is really independent of all possibilities. I don't know, but I don't think it is hard, yes? But do you agree that this is independent of how I have done these? Yes or no?
Yes.
So this means that I am, now I can solve the problem. So how much is that? 4,320. Yes? Yes? So I hope that you agree that even this problem was very simple, but if you really want to do it the other way around, it is not that certain, yes? 320. There are 320 odd digit numbers. 320 three-digit odd numbers without repetition of the digits. So you see, still, even though we haven't progressed a lot in this topic, but still we can solve a problem which was not that easy if you want to do it the other way around. Yes, is that clear? Yes or no? Okay. I think it's good to stop here, but we will continue this topic. So I recommend you to start reading the first 4 or 5 pages, which is about probability. But I will give you examples of probability later. Thank you very much.